Hello everyone. In this video, we shall see how convolution is applied on a digital image. Here, we shall see the step-by-step procedure. So we know that a digital image is a matrix of rows and columns. So in order to classify the images or for the purpose of prediction for classification, so we need to detect the important important features from an image. So for that we are going to apply the process of feature detection. So here we have a 3 by 3 filter. So whenever it is applied on this input image, so it will convolve or it will filter these particular three rows and columns. Why? Because the size of this filter is 3 by 3. 3 by 3 means it is having 3 rows and 3 columns. So whenever this filter is applied on this input image, so only the important features are detected and then a feature map is generated like this. In the next process, if you observe, the same filter is applied on the second column of the input image. Okay, so now these three rows and these three columns will be filtered and the relevant feature will be detected, which is presented over here. Next, in the same manner, now if you observe the feature detector or filter, it is now applied on the third column. Okay, so here these three rows and these three columns will be filtered and their corresponding feature map is generated in this manner. So next, so if we observe carefully, now the filter has moved by one column. So the corresponding feature map is generated here. Next, now if we observe the same filter, so here it has moved to one column further. Okay, so that the corresponding output will be 0. So now you may have a doubt how we are going to get the zeros. So it is the result of sum of products. That means this 0 will be multiplied by this 0. So 0 into 0 is 0 plus this 0 will be multiplied with this 0. Again 0 into 0 is 0. So 0 plus 0 is 0 again. Now 1, this 1 will be multiplied by this 0. Their product is again 0. Now this 1 will be multiplied by this 0. Their product is 0. This 0 is multiplied by 1. Their product is 0. In the same manner, so the entire filter coefficients, they will be multiplied with the image coordinates or pixels, so that their sum of products will be given. So here after filtering, the sum of products is 0. Okay, so in the next step, so as these three rows are completed, in the next step the filter will move to this row. Let us see the next step. So now if you observe, in the next step the filter has moved to the second row. Okay, so why? Because earlier it has completed all the first three rows. Now it has moved to the second row. That means, so this row and this row, these three rows are now filtered, so their product is displayed here. That means the corresponding feature map is generated here as 0. Now this filter will move to one column. Okay, now this has moved to one column further, so its corresponding feature map is shown here. Likewise, the process will be carried out. Now again the filter has moved by one column and feature map is generated here. Next, it has moved to another column here. It has started from here and their output is displayed here as 1. So don't confuse how you are going to get 1 means. So this particular coefficient will be multiplied by this coordinate and then their product will be summed with the product of this particular pixel and this particular coefficient. Likewise, so all the products will be added so that their sum will be generated as 1. So next, again the filter has moved to one column further, and again the feature map is generated. So this process will be continued further until all the feature maps are generated. So this process is carried out slowly in a step-by-step fashion. So now the feature maps are generated, all the feature maps are generated, and finally after convolution, the input image will be converted into these many feature maps. Okay, so generally we create many feature maps to obtain our first convolution layer. So this is a brief explanation about the process of convolution in image. Thank you. Please subscribe to my channel for further videos.